It is now my pleasure to introduce Dr. Joe Pancrazio, Vice President of Research at the University of Texas at Dallas. As Vice President of Research, Dr. Pancrazio oversees UTD's research enterprise, advancing innovation across engineering, computing, and emerging technologies that shape the future of our economy. Please join me in welcoming Dr. Joe Pancrazio.
So good morning. Good morning. All right, there you go. There you go. I'm not going to say howdy. Can't do that. So on behalf of the university, it's my great pleasure to welcome you to the Texas Quantum Economy Conference. And I have to tell you, our mayor is a hard act to follow. I got to tell you, we are so fortunate to have had a consistent legacy of leadership in Richardson, starting with Paul Velker, in my watch at least, that understood the importance of technology for a vibrant economy. We are so fortunate. Thank you, Mr. Mayor. So we are grateful that you all joined us on this Saturday morning to explore not only quantum science, but the emergence of the quantum economy, one that's poised to reshape industries, redefine global, not just national, global competitiveness, and strengthen the economic future of our state and the nation. Texas has always been bold in its ambitions, from energy to aerospace, from telecommunications to semiconductors. Our state has repeatedly demonstrated that when research excellence comes together with industry scale and entrepreneurial drive, new industries emerge and they thrive. Today, quantum science and engineering represent the next frontier in that same great Texas tradition. It's interesting, as Rashmi invited me to give comments, I usually do welcoming remarks. They're a little bit like, go team, rah, rah, okay, have a great day, seek somebody out, make new collaborations. And I started writing these, and I got really excited. And I think you're going to hear a little bit about why we're so excited, why I'm excited about this particular meeting, but also excited about the future. So we view quantum not as a niche discipline, but as a foundation. Okay? It has the capacity to touch computing, communications, material science, sensing, cybersecurity, and advanced manufacturing. Our faculty and students are working at the intersection of physics, electrical engineering, computer science, material science, chemistry, applied mathematics, and on, to push the boundaries of quantum devices, quantum materials, and quantum information systems. Our strengths at UT Dallas are rooted in interdisciplinary research. Our biggest and best buildings are all about interdisciplinary research. We don't put all the physicists in one building and all the mechanical engineers and all the bioengineers and the biologists all in different buildings. We put them all together, and great things happen. So, as you look at our materials and nanotechnology laboratories, researchers are designing and characterizing quantum-relevant materials, superconducting systems, two-dimensional materials, defect-engineered semiconductors, essential for scalable qubits and quantum sensors. In the microelectronics research facilities, teams are advancing fabrication techniques compatible with CMOS processes. Why? Well, it ensures that the quantum hardware development will remain aligned with semiconductor manufacturing realities. And in computer science and engineering, we're developing algorithms and error mitigation, and that's really important for functional qubits, that will allow industry to derive value out of the quantum systems as they continue to mature and become more commonplace. But we're not here today to talk about science and isolation. We're here to talk about translation. We're talking about building an innovation ecosystem that converts discovery into deployable technology, and that deployable technology to economic impact. The quantum economy is not going to be built by one institution. You said it very well, Mr. Mayor. It's going to be built by many institutions. And as one at the University of Texas, Dallas, I'm so delighted that we have faculty from Southern Methodist University, UT Arlington, and I understand other educators, because we don't view it as a competition as much as an opportunity for where a rising tide creates a positive effect for all institutions and all the students that we serve and families that we serve in the state. But we're going to need coordinated partnerships among those universities, industry leaders, startups, venture capital, workforce development programs, and state policymakers. It all has to be coordinated. Texas, though, is uniquely positioned to lead. We have a deep semiconductor heritage, anchored by global leaders in advanced manufacturing facilities. We have major research universities, not just us, okay, that have complementary strengths. And we have state government that understands, and a city government that understands the strategic importance of advanced technology to long-term economic vitality. At UT Dallas, we want to actively expand our engagement with industry partners in at least 3 critical domain areas. These are my favorite ones, okay? They're by no means exclusive. First, quantum enabling semiconductor devices. Why? Well, just walk around. You're going to see Texas Instruments all over this place, and so important to the history of the university, so important to the region. The fabrication, control, and scaling of qubits, whether superconducting, spin-based, photonic, whatever your particular flavor, depend on advances in materials, nanoscale patterning, cryogenic electronics, and integration with classical control systems. By aligning university research with industry roadmaps, okay, and that's where university faculty don't come and tell you what the problem is. We're going to ask the problems, so we understand what needs to be worked on to have impact, especially economic impact for the region. We can accelerate transition and translation from laboratory prototypes to manufacturable systems. I'm excited about next generation batteries. I think that some of you may know about that we're home to a DoD-supported battery prototyping facility called Beacons, which is primarily focused on accelerating new ventures. It's a facility that's unlike any other in North Texas. It's unlike any other in Texas, and I would argue unlike any in the nation. While batteries may not be the first thing that you think about when you think about quantum simulation and advanced material modeling in particular are already transforming how we understand ion transport, solid state, electrolytes, electrode interfaces, and degradation mechanisms. The ability to computationally design materials at the quantum level opens up entirely new pathways for safer, higher density, and longer lasting batteries. And it's not just for EVs. You want that grid to be stable. You want your data centers to be stable. And you want the output of your AI-based systems to be stable. You need a lot of great batteries to be able to maintain power levels. So, energy production and grid scale innovation, which our state leads in, it's not just peripheral, it's central to our economic resilience. The last area is advanced sensing technologies. Quantum sensors often offer unprecedented precision in measuring magnetic fields, gravitational gradients, time, and electromagnetic signals. Its capabilities have implications for navigation, for infrastructure monitoring, biomedical diagnostics, environmental sensing, and probably many other areas that'll keep going. So Texas industries in aerospace, defense, energy, and healthcare stand to greatly benefit significantly from breakthroughs in quantum. So, as Vice President for Research and Innovation, I believe our responsibility extends beyond just doing science for the sake of science and generating new knowledge. We have to move our discoveries from the bench to the public and marketplace with seamless IP strategies, and we work hard to do that. At UT Dallas, we want innovation and entrepreneurship opportunities to be available to all our students, our alumni, our faculty. Nevertheless, a robust quantum economy will depend on more than that. It'll depend on agile, venture-backed companies willing to take calculated risks, and a state ecosystem prepared to support them. Also, we would not exist here at the university if it wasn't for our educational mission. It's about the students who graduate and ultimately drive the technology-based economy. We have to build pathways for talent development that meet industry standards and demand, not just for PhDs in quantum physics, and Mr. Mayor said it right, but it's also for engineers, it's technicians, it's software developers, material scientists, manufacturing specialists who operate, maintain, and scale these technologies. Equally important are our partnerships with community colleges and industry certification programs. The quantum workforce requires highly skilled technicians who can handle working in clean rooms, operate cryogenic platforms, maintain precision instrumentation and equipment, and support semiconductor process flows. These roles are essential to scaling manufacturing and sustaining supply chains. This just in, our most critical supply chain vulnerability is highly trained and capable people. So we have a strong collaborative framework with community colleges, and it's more than just getting students that come and join us and for their later parts of their education. we've developed a workforce development consortium around semiconductor innovation, our North Texas Semiconductor Institute, and it provides a really tremendous foundation for expansion in the quantum space. Now, I imagine a future in which quantum simulation accelerates battery material discovery, where semiconductor fabrication facilities adapt to produce these quantum-compatible devices, and quantum sensors enhance our grid reliability and infrastructure monitoring across the state. To get there will require coordination, cooperation. Conferences like this are a great and important step to be able to convene stakeholders who don't usually sit at the table together. UT Dallas, we're eager to deepen collaborations through joint research centers. Michael Koldrubitz is here, great. You know, we are launching a quantum integrated systems center that's part of, it capitalizes on 30+ faculty who are working in quantum science and engineering. And we're really excited about what that future holds. And thank you for your leadership, Michael. And so, you know, we want industry partners to engage with our faculty early to help shape research agendas and anticipate real-world deployment limitations and challenges. We invite startups, okay, to leverage our facilities and our student talent. And we encourage our state leaders, really encourage our state leaders to continue fostering a policy environment that rewards long-term investment in advanced technologies. I think this is what really makes Texas special. Okay? The reason for the quantum economy is not just about technological supremacy. It's about economic opportunity. It's about creating these high-quality jobs in engineering, manufacturing, software development, advanced materials. It's about ensuring that Texas remains a destination, not just for national talent, but for global talent. Just in our great trend, just the tradition that we had in the semiconductor industry. And it really defines what it means to be a Texan, right? Okay? You know, put the six-shooter aside. It's about technology, and it's about fintech. And eventually healthcare is emerging areas. We want to be that hub for innovation growth for the entire world, okay? Closing, thank you for the invitation. And as I said, I usually come up and give rah-rah statements and tell you to have a great day, but I got so excited, you know, with being able to have the opportunity to address you today. Thank you and have a great day.